In this session, I will try to solve a couple of limits with absolute value. Absolute value, this is a definition of absolute value. Absolute value of x equals to exactly the same number x if x is positive, greater than 0, of course, or equal to 0. However, if the quantity inside x is negative, we will put extra negative to make the value positive. That means that if we understand this definition, then we are good to go. And absolute value of x, this is the graph. For the positive part of the x-axis, we have just the function y equals to x, this one. And for the negative, we have negative x, which, however, the output negative x is still positive. We may notice because the graph is placed above the x-axis. Above the x-axis in the Cartesian plane, values are positive. Okay, let's look at a couple of functions and check the behavior near a certain values, but all of the functions will be with absolute value. Okay, just this one, which, however, I can write here. What is the limit of absolute value of x if x approaches 0? 0, of course, is in the domain. That means x equals to 0 is in the domain of the function, because domain are all of the real numbers. As we can see, we have continuous function. We do have this sharp corner at 0, but it's still continuity. Then, when we have continuous function, we can just substitute absolute value of 0. Of course, it is 0. The limit is 0, and we may notice on the graph. That means this limit is 0. What about this one? The next example, limit as x approaches 4 of the function absolute value of x minus 3. Again, 4 is in the domain of this function. Then we can just substitute 4 minus 3, absolute value of 1. I was gonna say 1. I don't know. Okay, let me write a little bit lower. If we substitute again, we have 1, absolute value of 1 is 1. Okay. If we draw this function absolute value of x minus 3 is also the V shape, but the x-intercept is 3. That means the V will be attached at 3. We're basically shifting horizontally 3 units to the right. Okay, that means this is, and at 4, the limit is the same like the value. That's the limit, which actually I suppose to, it's not exactly, I mean, we're not looking at the value, we're looking at the limit, but the limit is the same like the value. Okay, for the continuous function. The next example, limit as x approaches 0 and absolute value of x over x. Now we may notice we do have 0 over 0, indeterminate form. Then we have to find out a common factor. I mean, first of all, we almost see is that 0, absolute value of x over x. In order to cancel out, we have to rewrite without the absolute value. I mean, we will definitely need to investigate the right-hand side, and we need to investigate the left-hand side at 0. So let's see how this function behaves. Okay, limit as x approaches 0 from the right-hand side, this is x, absolute value of x. X on the right-hand side at 0 is positive. That means absolute value of positive numbers are just these numbers. X over x, it is 1. That means this limit is 1. Now, let's rewrite this one. This is x. Absolute value of x. Now, x is 0 from the left-hand side. That means that x, this x is negative. I have to make it positive with this extra negative. Okay, that means this is still positive because this quantity, the x itself, is negative. And I'm making positive based on the definition, based on the first slide. And now, after cancelling out, we have negative left, -1. That means limit on the right is +1, limit on the left is -1. Then we can say the entire limit does not exist because one-sided limits are different. We can draw a function. Limit on the right-hand side is 1. It's actually constant function. And on the left-hand side is -1. No values at 0. Yes, value at 0 does not exist. And the one-sided limits are different. Okay, that means limit. This indeterminate form, we actually end up having undefined. Yeah, and this is the justification. Okay. Another rational function, limit as x approaches free from the right-hand side, 2x minus 6 divided by x minus 3. When we substitute 3, exactly 3, 2 times 3 minus 6 is 0, and 3 minus 3 is 0. We have indeterminate form. Okay, 0 over 0. We know if we see 0 over 0, function on the top and function on the bottom has something in common at 3, the common factor. Let's try to find out. Okay, that means I can say x approaches 3 from the right-hand side. I can factor out 2. Okay, and now, again, before cancelling out, we have to rewrite this expression without absolute value. That means let's check. Quantity x minus 3. Let's check if it's positive. I can maybe say here, this quantity. We have to figure out if this expression is positive or negative, because if it's positive, if x minus 3 is positive, we can rewrite as a x minus 3. But if x minus 3 is negative, we will rewrite as a quantity x minus 3 with extra negative. Okay, that means this is the point. Let's check. That x is free from the right-hand side, and this is minus 3. Free from the right-hand side is, for instance, 3.01 minus 3. When we subtract this, we actually getting positive, greater than 0. Then I can rewrite simply ignoring absolute value, like this, okay, because it's positive. And now this is the common factor. The final answer is 2. Okay, really nice. 0 over 0, indeterminate form, and we actually receive a finite number. Okay, example number, the next one, because this is the presentation about the indeterminate forms. It's the part of the presentation just about the absolute value examples. Okay, x approaches 5 from the right. 15 minus 15, 0. 5 minus 5, 0. Again, let's check. We need to find common factor. Limit as x approaches 5 from the right-hand side. We can factor out 3, 5 minus x. And we do have 5 minus x, but we have to make sure. If the quantity 5 minus x is positive, greater than 0, then we can rewrite as a 5 minus x. If this is positive, we can, if 5 minus x is negative, okay, then we can rewrite quantity 5 minus x with extra negative. Okay, let's check. This is 5 minus, and this is 5 from the right-hand side. Like 5.01. 5 minus 5.01 is actually negative number, less than 0. Okay, that means this is that case. I will put the extra negative. Then cancelling out the common factor, the answer, the final answer is -3. That's in, please notice, even if x is approaches number 5 from the right-hand side, still the answer is negative, because sometimes we tend to think that the answer should be positive. Okay, next one. Oh, multiple choice. Evaluate the limit x approaches 3 from the right-hand side. 3 minus x over absolute value of the quantity 12 minus 4x. 3 minus 3, 0. Okay, I will write. Oh, I don't know why I'm getting this. Okay, it's definitely 0 over 0. Okay, that means I can write 0 over. Oh, too fast. Okay, 0 over 0. Then we know what to do. We have to find a common factor and cancel out, but in between, rewrite the expression without the absolute value. Okay, this is good. Now we can factor out 4. Oh, let me actually put that 4 out on this side, but I still don't know. If this quantity is positive, then it will stay like this. If this quantity, which actually is still inside the absolute value, it's negative, I will put extra negative sign. Okay, let's check. 3 minus x times 4. Let's check. This is 3. This is 3 from the right-hand side. Times 4, of course, will not change the sign. 3 minus 3.01, this is negative quantity. That means if this is negative, I have to put negative, because we remember if the quantity is negative, 3 minus x, okay, absolute value equals, we're not changing anything, or we're changing this way if this quantity is positive or this quantity is negative. Okay, definition. Okay, that we have this, we can cancel out common factor, and I think the final answer is negative 1/4. Again, x approaches number from the right-hand side, but the answer is negative. Yeah, please be careful. And it was 0 over 0. I just couldn't write down. Okay, and then I have this one. 14 minus 2x over quantity, absolute value of the quantity 7 minus x. X approaches 7 from the right-hand side. Okay, 14 minus 14, 0. 7 minus 7, 0. Okay, 0 over 0. Let's find a common factor, cancel out, and then get the answer. Okay, we can factor out 2, 7 minus x, and we do have 7 minus x. But we have to check if 7 minus x quantity is, if it's positive, we can write like this. If it's negative, we will write like this. That means this, if it's positive, or if it's negative. Let's check. Maybe we can check here. This is 7 from the right-hand side. 7 minus 7.1, it's negative number. If it's negative, we will put that negative. The final answer is 2 over negative 1, negative 2. Okay, and let's do one more. Okay, x approaches 2 from the left-hand side. X squared minus 4 and x times absolute value of x minus 2. When we substitute 2, we can see, we can definitely see we're getting 0 over 0. Okay, so now what we will do? We have to find a common factor. Quadratic expression x squared minus 4, we can factor out this way. We all know this. And then we have, let me switch because I need the place for the negative just in case. X minus 2 times x. But this one, I have to make sure if it's positive or negative. If it's positive, it will stay like it is. If this quantity is negative, I will make it negative. I will put extra negative to make it positive, of course. Okay, that means let's check. This is 2 from the left minus 2. 2 from the left is 1.999. 1.9 minus 2, wow, again is negative. Then we will put negative. Okay. Yeah, we can see because of this quantity, I can even say x minus 2 can be rewrite as a x minus 2 or can be rewrite as a x minus 2 negative. If this quantity is positive, if this quantity is negative. This is just the definition. Okay, that means now we have everything. We can cancel out 1, 1. We will end up having x plus 2 over negative x. We can see negative x. Substituting now 2, we will have 4 over negative 2. The final answer is negative 2. So many, yeah, I'm just substituting negative 2. And we have this answer. Okay, I hope you did enjoy a couple of examples of the function with absolute value and its limits with indeterminate forms. Thank you.